Audio is not recorded. I have to do it again for decalcification. Yeah, when we say here, our decalcification is of course removing the calcium like from our bones, our teeth, and we have like several things that we use on this one. And here, class, as what I've said, like it is performed after fixation before dehydration, and it is necessary for proper tissue sectioning, especially if you're handling this kind of samples. So recommended temperature is from temperature around 18 to degrees Celsius, 24 to 48 hours for our time for decalcification, and usually the volume that we are using for decalcification is around 20 times. Okay, next. Here are the following factors. Of course, if it is heavily calcified, it may take time, the temperature as well. Please take note that heat uh, is discouraged because it may damage tissue, and of course, the proper volume must be followed too. And too rapid calcium removal or decalcification, it may harm the tissue and it will lose its integrity. Okay. Yeah, so in decalcification, our formic acid is better in preservation and staining quality. On the other hand, our nitric acid is 2 times faster than formic acid. And please use around greater than 1 ounce of acid per gram of tissue, and you must change solution once or twice daily until the decalcification is complete and it is monitored. Okay, for our acid, we have our nitric acid. It's a strong acid, very rapid, around times 2, as what I've told you earlier, minimal distortion for routine decalcification. And here we recommend around 5 to 10% of the concentration, as it inhibits as well the nuclear staining, and there will be yellow discoloration from uh, the stains and damages our tissues. Okay, please take note as well of this. Our 10% aqueous nitric acid, it composed of nitric acid and water, rapid action for urgent biopsies, and the decalcification time around 12 to 24 hours. Next is that we have the hydrochloric acid, which it is considered as a strong acid, slower uh, this form acid, but it's a good nuclear stain. And recommended use for surface decalcification of tissue blocks around 1% and 70% alcohol. More tissue distortion than nitric acid. Okay, that one is an OT. Next is our von Ebner's fluid. It is used for our small samples, small tissues such as teeth or small bones, which it will take around 3 to 5 days for its decalcification. It's composed of 36% of saturated sodium chloride and concentrated hydrochloric acid and distilled water. Okay, for our formic acid, it is a moderate acid, moderate acting. Everything is moderate in formic acid, and it is used for our post-mortem tissue, and it's not recommended for our urgent exams, such as another one, the aqueous formic acid, still not an excellent for urgent biopsy. However, it is better for immunohistochemical staining for still small bones and teeth, and it's gentle and is composed of formic acid plus 10% formal saline. Okay. Next, formic acid and sodium citrate is not suitable for urgent biopsies, and it's considered recommended use for our autopsy, bone marrow, and cartilage research. And it's also buffered, this formic acid sodium citrate. It's composed of 20% aqueous sodium citrate and 45% of our formic acid. Next, formal nitric acid. It is composed of formalin and nitric acid. So, less tissue damage, good staining, recommended use for our urgent biopsies. And for nitric acid, we are removing it on the yellow color removal for 5% sodium sulfate with running water for 12 hours and 0.1% urea. It prevents the yellow discoloration in concentrated nitric acid, and please use it inside a fume hood for the safety of your health. The calcification time, it may take 1 to 3 days. Okay. Next is perennis fluid. Please take note that it is composed of chromic acid and alcohol. This calcific it acts as decalcifier and tissue softener. So, routine decalcification generally soften any decalcification. It prevents maceration due to the chromic acid and alcohol. Okay. Next, fluoroglycine nitric acid. It is the fastest decalcifier. Since it's a nitric acid base urgent works, it's not recommended because somehow it will produce poor nuclear staining and there will be yellow discoloration. Okay, next acetic acid. It's like a very weak one, not urgent, do not layer stain, no washing required, weak organic acid. And yes, sulfuric acid is the weakest calcifier, it's generated for our minute bone pieces, and it's very weak acid. Okay? Yeah, so here the chromic acid or our Fleming is dual purpose general use, oxidizing agent, corrosive, carcinogenic, environmental toxin to harmful skin mucus. Okay? Next, we have this one, the citric acid, citric buffer, with organic acid buffer, no distortion, cell tissue studies, and it's good for the nuclear and cytoplasm. Okay, studies. Okay, so please take note of these ones, dual purpose. Yeah, here. And yeah, we have our chelating agents where it binds on the calcium, the other substances, the other metal ions will bind to calcium. They will form weakly dissociated insoluble complexes, aiding in calcium removal. What happened here, it will form a stable non-ionized complex with calcium, which is then removed from our tissue. Okay, so here class, this is like the example reaction. EDTA plus calcium equals EDTA, which is like calcium complex equals to, it will have insoluble. Most common agent is our EDTA, ethylene diamine tetraacetic acid, which it has like two types, the versin and sequestrine. Okay, versin 2, sequestrine is K3. Let's continue on this one. Okay, so here, yeah, slow acting, especially delicate tissue like IHC, and yeah, that one. Here, ion exchange resins is remove the calcium from the formic acid, enhance like solubility, accelerating its removal from the tissue. So here, ion exchange resins, synthetic resin, they use to speed up decalcification. So hastens decalcification without damaging tissue structure. Next is here, not recommended with mineral oils in nitric acid and hydrochloric acid. So here are the following here. Yeah, let's continue. Electrophoresis is like this one, the microwave or the cathode, remove the liquefying solution. So we are just basically in electrophoresis, we're using energy. Okay. Yeah. So next here on electrophoresis, we are using some chelating agents, and yes, solutions use this one, 80% formic acid, concentrated chloric acid, and here. Yeah, so a lot. I'll just give you a reading assignment for that. Okay, so here are the methods. First, we have the physical method, which we are using it for touching and so on. And yeah, next we have our X-ray or radiography method, which it uses X-ray equipment. It's quite expensive, but it's convenient. Okay, it's not suitable for mercury chloride fixed tissues. Okay, let's continue. So here we have the chemical method, which are free calcium ions. That one. Here, it's simple, reliable, convenient, and good for routine use. So first, our radio preparation needs fluid every change. Okay, so please take note of that class. I'll just leave this reading assignment to you. I hope it's okay. Yeah. So let's continue on the next slide. Okay. Yeah. Let's continue here. Yeah, so here in tissue softener, we have like different supplementary softening agents, and we need to have a precise timing, so on. Yeah, so here, please take note of that, the tissue softeners in histopathology. Uh, yeah, like firstly, like contains nitric acid, parenese fluid. Second is 4% phenol, and then here, Moliflex. That one, please take time here. Let me go on the next slide. Here, at 4.2% hydrochloric acid. Yeah, so we must dilute hydrochloric acid solution. Again, dilute hydrochloric acid solution. Next, here, HCl hydrochloric solution that in ethanol, so short exposure is suitable for surface softening, preserves nuclear better than aqueous HCl. So it is our 1% HCl in 70% alcohol. Okay, that one. So that will be the end of the tissue decalcification. Thank you so much for listening.